we made it. Hello, everybody. Are you okay?
82 plus 8.
Take it as a yes.
Okay, Roger, I'm gonna put the code down.
Guys, don't talk on your side because we can hear it here. Right. Before I start the lesson, what do I always do? Keep those hands clean. Okay? And don't spread germs. Stay at home. Okay. Before I continue with start analytical geometry, I had to finish this question from this worksheet that we never finished these last 3 questions. And then I've got one more parabola question, and then we'll go on to the analytical geometry. But because it's functions, then we are still in paper 1. All right. So guys, just make sure you keep very quiet on your side of the camera. Okay. If you remember, we started this yesterday. We've got the 2 roots, the X-Intercepts, -3, 0, 5, 0. Worked out the Y-intercept, 0, 15. And yesterday we worked out the turning point, 116. And this is our parabola F. And the equation of the parabola F, as you can see and remember, we got it yesterday, f of x equals minus x squared plus 2x plus 15. All right, so that's what we had from yesterday. All right, now I've rewritten the 3 questions we didn't finish on the board here. I'm not sure if you can see, but they're all these different values of k. Those last sort of questions they have at the end of the question section. They're gonna get like easy, and then these 2 are like middle but tricky. These 2 you might learn something. The first thing is they're saying, if my parabola f of x, guys, if that equals to k, the first question is, so values of k for the graph f to have 2 distinct roots. All right, remember, a root is where your graph comes the x-axis, but in these type of questions, we put our ruler on the x-axis, and that is obviously where 1 equals to 0, equals to 0, and that's where we see that there are my roots. But if I were to go down, let's say to where k equals to -1, I'm still going to have 2 distinct roots. So we're vertically shifting down the x-axis. If I go down a bit more, let's pretend that is the line y equals to -3. It would be -3. We'll have 2 distinct roots. And I think that will happen all the way to -infinity. So let's change the direction. If we vertically shift our x-axis up, do you see I still have 2 roots? I still have 2 roots. I still have 2 roots. Aha! But if we go as high as the maximum value where y equals to 16, so k would equals to 16, you can see then and if we go higher than that, then my x-axis, which I'm raising, wouldn't touch these. So your answer for this would just be k must be smaller than 16. K must be any value smaller than 16. Some of you like to go k element, but then you have to put the smallest value on the left, the biggest on the right. Round. Remember, we're not doing range. Range, we would have included the maximum value. We are talking for what values of k are we going to have 2 distinct roots, where the ruler would cut that parabola in 2 places. All right, so that's the first question, done and dusted. Probably 2 marks maximum, maybe only 1. Right, the second question, we actually did this. Hello?
Ma'am, what worksheet are we using?
What?
What worksheet are we using?
do you remember the parabola that I started yesterday? If you were on the group yesterday, I never finished these last 3 questions. Okay, so I'm just doing them now. Okay. So the second question, number B, said for what values of k, well, then it said will f of x plus k equals 0 have 2 distinct roots. Now this would also probably be about 2 marks, but we've done this one before on a different example. So if you remember, if you take the plus k to the other side, you get f of x equals to negative k. Now I don't want the negative k, that makes my life too hard. But you remember if I times both sides by -1, then I'll get minus f of x equals to a positive k. Now you must all know by now, I did this the other day, so if you've been following the lessons, minus f of x is a reflection about the x-axis. So you take the original graph and you're going to reflect it about the x-axis. So do you agree if I take this graph and reflect it about the horizontal x-axis, my turning point will come down here somewhere. So let's just put it there. So x would stay positive 1, but you see y has now come down. So the y value would be minus 16. So I'll change the color. So just so you can see by drawing the reflected parabola minus f of x about the x-axis, we will get a happy parabola. And the turning point has moved down to where x is 1, but y is minus 16. If I just extend, my y-axis, it will cut there at 0 and minus 15. Because look, that was plus 15. It will still come there and it will go through that route. Okay, so that's just minus f of x if the original parabola is x. So now, do you understand? I'm saying for what values of k will this green parabola have 2 distinct roots? Now, if I go below minus 16, you can see it's not going to cut at all. If I go to exactly where y is 16, that is the line y equals 16, which would make that the line minus 16, k equals to minus 16, then you can see it's only cutting the graph once. But if I go any value higher than where y or k is minus 16, to agree it's going to cut the parabola in 2 distinct places. So for this example, you would just say k must be greater than negative 16. And I got that by reflecting the original parabola about the x-axis because we've changed y to negative. Some of you prefer this notation. Sorry, wrong variable. So you would go k is an element from minus 16 up to positive infinity, round. Okay, so those are those 2 questions. We've done this one before. Now let's look at the last one. The last question is getting very popular these days, all right? So I want you just to, if at all possible, ignore the green parabola. Just kind of, let's take it as much away as possible. Let's just look at the original parabola that was drawn by me originally. So you can see here's the original parabola with the turning point 1 and 16, the 2 roots, 5 and 0, 1 set 0 and 15, and there is the minus 3 0, okay? So this is now still going back to, this is the graph F. Now the third question, number C, said if f of x, the parabola, equals to k, determine the values of k for us to have 2, but they want positive unequal roots. Okay, so they're being a little bit more specific here. It could be 3 marks, but I'll leave it at 2. So they want 2, but they must both be positive and different, not the same. So now if I just start down here, can you see I have 2 roots, 2 intercepts, but this one is positive because look, it's on the positive x side, whereas this root is negative. It's on the negative x side. If I go higher, I have 2 different unequal roots, but again, unfortunately, one is positive and one is negative. Go higher. I still have 2 distinct roots, but look, one is positive, one is negative. Now if we go as high as 15, so that would be the line y equals to 15, which means k would be 15. Just watch carefully. We have 1 positive root. Now, I can't really call that positive or negative because it's on the y-axis. However, do you all agree if I go just a little bit higher than that, any horizontal line a little bit higher than the y-intercept, do you see I have 2 intercepts? They are different, but they are both positive. And again, you can see if I do another line here, look, 2 unequal, but on the positive side. However, if I get as high as 16, then I only have 1 root, not 2 different roots. So our answer is actually k must be between those 2 values. So I would write up my answer, k must be greater than 15, but smaller than 16. So in other words, k can be any value between them, which is infinite answers, guys. They're infinite fractions that go here. Some of you to write your answer as k on the left, the bigger on the right, and it means we use round brackets. Interval notation. Okay, so now we've yesterday's work. Let's look at one more parabola, just one more, which is still in your paper 1. And then I'm going to change over to analytical geometry. All right. The question that I have for you today is I'm giving you a parabola. Let's change it to G. I'm sick of F. Its equation is minus x squared minus 3x plus 4. Now, I think that all of you can see the coefficient of your x squared is negative. So we definitely sad parabola. Now, the first question, 1.1, is they want us the graph G, this graph, but they want us to rewrite the form y equals x squared plus q. Point formula, all right? Now, just to remind you, whatever your turning point is, the y value of the turning point, if it's sad, is going to be your maximum, all right? Now, a lot of you get very confused with this, so I hope you, what you do is you take your axis of symmetry, your turning points, and to get the p, what you must do is times it by a negative 1. So if your x value, the axis of symmetry, is 1, if the y value of the turning point, let's say, was positive 4, then that is your original. But that's not the answer. I'm just reminding you that the axis of symmetry with the reverse sign is what we put here, and the minimum, so the y value we put there. Now, a lot of you of the parabola. So we have standard form, ax squared plus bx plus c, standard form. This is called the turning point formula because we can get the turning point very fast. And we looked twice now at the root formula when we were getting the equation when I gave you both the roots, which are your x-intercepts and another coordinate. Now, what is whether I rewrite the parabola in either of these three ways, that A is the same. So in other words, the A in this parabola is minus 1. Do you see it's minus, it goes to minus. So if I'm rewriting it in the turning point formula, the A value is going to stay the same. So know that it's going to be minus 1 bracket. Let's just keep that on ice. Now, by the way, some schools will teach their students to compare from there to get it into that format. But at Greenside, because they won't specify in matric, we just teach you, get the turning point. So the axis of symmetry we know is minus b over 2a. So we use it from the original graph. So do you agree that b is minus 3? So it's minus 3 over 2 times a, and a is negative 1. The axis of symmetry, we're going to get a positive over a negative. So the quotient is negative 3 over 2, which is 1.5. So it's negative 3 over 2. That's my axis of symmetry. But now you don't write it here as negative 3 over 2. You change it to the reverse sign, which is positive 3 over 2. So your axis of symmetry goes in there, but we change the sign. And that is a squared. Okay, how do we get y value at the turning point? Remember, you do your f of x notation. Replace your x with what we got for the axis of symmetry, but the real one, the minus 3 over 2, because that x value lies on the parabola. So we will sub that into the original parabola. So we have minus 3 over 2 squared minus 3 times minus 3 over 2 plus 4. Now you just have to put that in your Casio. Now guys, a lot of you, I watch you in class, you go like minus, bracket, up, down, minus 3 over 2, close bracket, squared, and it takes a long time. A very quick way of doing this is take the x value. So if you go up, down, and just go minus 3 over 2, then go equals. Bring it to the right, so it's sitting there, and then go AC or clear. That is now your answer. So a quick way of plugging this in my calculator, I just go minus answer squared minus 3 answer plus 4. So you see that's sped that operation up quite significantly. And I'm going to get the answer of 25 over 4, which just for interest is 6 1/4. Now we don't mind if you work with improper fractions, but now this is the y value for turning point. So the x value was minus 3 over 2. The y value for turning point is 6 1/4, or we could say 25 over 4, turning point. So the axis of symmetry, we put in the bracket with the reverse sign. Now the q value, that value there is the maximum value, the y value for the turning point. But guys, we keep the original sign. So the original sign was a positive 6 1/4. So this is plus 6 1/4, or you could have written here plus 25 over 4. So that is how we got our parabola from standard form into the turning point formula. 1 mark for the A, 1 mark for your correct axis of symmetry in the bracket, and 1 mark there for the y value, the q of the turning point. Okay, if you are ever asked to shift a parabola, let's say they say shift it 3 to the left, 2 up. Always get your parabola in the turning point formula. Point, and then you follow the instruction and you get the new turning point, and you would keep the A and just put in your new turning point. Just remember to change the sign of the axis of symmetry. Okay, now what else? Let's say they said draw this parabola. All right, now in order to draw it, we've actually got 2 out of the 4 pieces of information. We've got the equation in its standard form, which is minus 1x squared, look here, minus 1x squared minus 3x plus 4, but we also have the equation now in its turning point format. So if you think about one, we don't need to plot this. The shape of this parabola, because the coefficient of x squared is negative, so the a value is negative. So number 2, do you understand by the previous question, if this is question 1.2, the turning point in this question. So the turning point, you don't have to restart from scratch and go from scratch because we've got it now. So there is my turning point. Now, we obviously still need the y-intercept, and to get the y-intercept of any graph, remember we just let x be naught. So if you go to standard form, wherever there's an x, that term will be 0. So it's cutting the axis at. So it's going to cut, x will be naught, y is 4. The last thing, we just need the x-intercepts, right? So you let y be 0. I'm going to work with this. So 0 equals 1x squared minus 3x plus 4. Now, I tell my students every lesson, never factorize a quadratic trinomial that starts with a negative. So take out that negative 1 as a common factor, change to a positive, reverse to a positive, change to a negative. You can divide both sides by the negative 1. Naught over negative 1 will stay naught. So I just need to now factorize this quadratic trinomial, which is actually an easy one to factorize. Don't drop the equation. This tells me we're looking for the difference of 3 from 1 and 4. So it's going to be 1x, 1x, 1 and 4. This last side being negative tells me my brackets will have difference. The biggest product multiple will get the first sign. So who's bigger, 1x or x? 4x. Multiple gets the sign there, which means that must be a minus. Once you've factorized it, just quickly in your head, FOIL it, and you will see you've done that correctly because there's quite a few marks there. It's x is going to be 1 or x is going to be negative 4. Now, I have everything I need to draw this parabola, so it's just a quick revision on how to draw a parabola. If you remember, I said to my students, I would suggest draw your axes in a pen. So if you make a mistake, when you erase out your axes won't erase, they will stay there just for a few seconds. I also told my students, go to the axis of symmetry, minus 3 over 2. Not to scale, just draw a vertical line. That is the x equals to minus 3 over 2, minus 1.5. So your parabola is going to be on that red line, not on the y-axis. Okay, what I do next, lamb chops, is I put in my x-intercepts. You see, one is plus 1 and one is minus 4. Now, the x-intercepts or roots must equidistant to your axis. And minus 4, and always write them as coordinates. And then from there to there, that would be my plus 1 and 0. You must always write your x and y intercepts and your turning point as coordinates. Now let's look at the turning point. So it's turning on the red line, but 6. Don't draw these to scale. So the turning point, x is minus 1.5, y is positive 6.25. So it's going to basically go from the turning point symmetrically down. If you miss your point, just make it a bit bigger, symmetrically down. Okay, if you miss your point, make it a bit bigger. Once you've drawn your beautiful parabola, then go to y-intercept. And remember, we worked out as cutting the y into plus 4. X is naught always, and y would be 4. So this is my parabola G. Label it G. Don't label it G of X. that is actually incorrect because you're labeling your graph as y. You label your graph just with the letter, in this example, G. All right, so now we've gone over drawing a parabola. We've done all of that. There's just one further question that I'm going to bring K in. So look for this question. There's two ways we could do it, grade 11s. But let's first see what the question is. Let's say they said, if H, now H is not G, so we have a new graph. If the graph H, but now notice they're going to use the exact same first two terms, is minus x squared minus 3x. Instead of the y 4, they're going K. All right? The y-intercept. Now, sometimes what they might say is determine the values of K such that the graph H of X has no, actually we said the graph H has no real roots. All right. Again, this will be back to our question. There's two ways to do it by using the graphs. I recommend saying what I'm going to show you. It's not hard. Do you agree when the y value of the turning point is up there? Look, we've gone all the way up to 6 1/4. Then you can see we have two roots, right? Now, if we were to bring this parabola, translate it down by exactly 6 1/4 units, do we all agree that the new parabola would then be there? But you've got to understand, I still have one real root. In fact, it's turning on the x-axis, which would make your discriminant equals to 0. So they said we want no real roots. So do you understand, for no real roots, we want our parabola to be just below that x-axis, where there's no x-intercept. So we must translate the original red parabola just a little bit more than 6 1/4. But you see, if the y-intercept was sitting there at +4, you see that is also going to be translated down the same vertical length. So when it was turning on the x-axis, the new y-intercept would have been 0, and if you go 6 1/4 minus the 4, you'd be sitting on -2 1/4. That would be the new y-intercept, which is K, but we need it to be a little bit less than that. Go down just a bit more. So my answer is K must be any value smaller than our new y-intercept, which would be -2 1/4. If you still don't understand the concept of the translation down, there's a backup plan. You could say, well, your discriminant must be smaller than 0 for non-real roots. So you could just take your graph minus x squared minus 3x plus k and say, okay, let's take the discriminant and make it smaller than 0. So b squared minus 4ac must be smaller than 0. So b is -3 squared minus 4 times a, which is -1 times c, which is k. And if that is smaller than 0, we have no real roots, which would make that 9 plus 4k. So 4k must be smaller than -9, and that's how we got k is smaller than -9 divided by 4. And guys, that is the same as -2 1/4. Now that takes more time. So for the students who can use the graph, visually see the translation, you get full marks for going straight into your answer. And again, some of you prefer the notation, K is an element, but then start with the smallest, which is down here, -infinity, and then on the right must be the bigger of the two values. But guys, we're not including it. Because remember, if you invert, that means it's turning on the x-axis. And if it's turning on the x-axis, then we still have one equal real rational root. Okay, so guys, that's all I want you to do today on the parabola. My, how time flies. But I've got a feeling we started 4 to 5 minutes late. So that means I can move on and start. So today is a typical day we might get cut off because I'm not too sure exactly when we started. But I will ask you guys after the lesson where I'm going to start tomorrow. But it's very fundamentally important. I want you to understand I'm now going into paper 2. And in paper 2, I'm specifically going into analytical geometry. And it is a very easy and fun section. We can slowly raise the level. We're going to the next 2 lessons, take you up to the grade 11 level. But we're going to start with distance formula. Distance formula is for length. Anything to do with a length, the distance. Now, if you recall, I did give you a worksheet. Let's see if I can find that worksheet. I will repost it on the group. I posted this worksheet. And I said you should all be able to do question 1. Because question 1 is very grade 10. You'd be very lucky indeed to get a question like question 1 in a grade 11 or 12 exam. It's more grade 10. But basically, they drew us a triangle, and the triangle, let's just put the 3 vertices on first. So the one vertex was sitting at -3 and 4. So let's just make that there, -3 and 4. And that is point N for Nelson Mandela. The other vertex was sitting here where X is 4, Y is 5, so up there, 4 and 5. And that was labeled L, L for love. And the third vertex was down here where X is 2 and Y is -1. And it was M, M for mother, -2, 1. Then they joined these 3 vertices and we've got a triangle. All right. Now the one I did, just so it's the same, it was actually above the origin, just so my diagram matches your diagram. Okay. Remember, I've not drawn this to scale. But if I say, is this what type of triangle is it? You can't measure and measure and measure with the ruler and then come to a conclusion because we're not drawing these to scale. So if the question says, what type of triangle? You've got 3 options. You've got a scalene, and a scalene triangle just means all 3 sides have a different length. You have an isosceles triangle, and an isosceles triangle, any 2 sides are equal in length. It doesn't have to be the top 2, it could be on the side like that. And then you have your equilateral. Equilateral. Okay, my spelling is not my strongest, but basically equal, that would mean all 3 sides are equal in length, and we know the angles would be equal as well, 60 degrees. But when it comes to this section, we're looking at lengths. So you've got to find the length of all 3 sides. So the distance formula you should know is d for distance equals a square root. You take the difference in the x values of a coordinate squared plus the difference in the y values squared. Now, don't keep it as d, otherwise how is the teacher going to mark this? So let's say we're looking for the length of nm. Replace the d with a capital N, m, equals, under the square root. So let's say I start with this x, -2, minus this x, which is -3, and be very careful when you're going minus, minus. Maybe use square brackets. Plus, I now need to start with this y minus this y squared. Okay, you can keep your answer in square root format. Just for interest, that is +3. So minus 2 plus 3 becomes 1, and 1 squared is just 1. Sorry, I might be being, that is 3, yeah, positive 3 minus 2, so it's 1 squared is 1 plus 1 minus 4. Degree 1 minus 4 is negative 3, but if you square it, you're going to get 9. So the length, now I've just got a feeling this is wrong because I don't remember that being any answer. So I just want to check I've copied this down right. Don't panic. Minus 4, 2, aha. Now you see, that can't be negative 2 because x is positive. So that is my mistake. So let's just go back. There's a small mistake. So that's 2 plus 3, which is 5 squared is 25. So we're actually going to get an answer that is different. So we're going to get 34, but I still remember that being wrong. Guys, I think the lesson's come to an end. You can see what I'm doing. I've made, oh, look, that must be minus 1. 2 careless errors. Watch, you see, that didn't make sense. You're actually going to get an answer. I think it's going to be 40 or 50. I'll do this again tomorrow. Sorry, I'm flustered because I've run out of time. Yeah?
3 minutes still.
Oh, 3. Okay, thank you. Then let's just start that again. Okay? You see, when you write rubbish, you get rubbish. And I wrote this corner totally and utterly incorrectly, and that is why my answer was illogical. Okay, so let's do that again. So you replace the d with nm equals under a square root. So we take the x of the one, which is positive 2, minus the x of the other, which is minus 3. Okay, we're going to square that. Plus, then if you start it here, you must come here. We take that y minus that y. And we're going to take that and square it. And then square root the final answer. So this is going to be hopefully better. 2 plus 3 is 5. 5 squared is going to be 25. Plus, minus 1 minus 4 is negative 5. But if you square negative 5, you get another 25. That's more like it. So we're going to get surd 50. Surd 50 is the same as 5 surd 2. But just for interest, they didn't say in simplest surd form, so you can leave it like that. Now, I've probably got 1 minute, so you're going to have to find all 3 lengths. I want you to find ML and NL. You can't just find 2. Because if 2 are the same, you can't assume that the third one will be different. So you see, you're going to find all 3 sides, and in this example, you will get 2 sides are equal and 1 isn't, and therefore you will say it's an isosceles triangle, but then mention to the examiner which 2 sides you got equal in length. I'll let you finish that for homework, and then I'll give you a few revision exercises of algebra today, just to get you doing something for tomorrow. I'll see you tomorrow, guys. Sorry about the mistake. Yes.
Everything you did today, like earlier, you're going to post on the group, right?
Yeah, definitely.
Okay.
Always post everything on the group. Okay, so stay happy, stay positive, don't panic. Kululeka. Mwah.